Okay, example number 1. A progressive wave is represented by this equation here. So y and x are in centimeters and t is in seconds. Okay, so we have to determine the angular frequency, wavelength, period, frequency, and wave speed. And then we also have to sketch the displacement against distance graph for progressive wave above in range of from x less than or equal to 0 and then less than x greater or equal to 0 and then x less than or equal to lambda. Okay, at time t equal to 0 seconds. And then repeat question B for time t equal to 0.5 of the period. And then sketch the displacement against time graph for particle at x equal to 0 in range of this, and then this is okay. So I'm just gonna draw, do it here. Oh wait, have to change the template to look. Yeah. Okay. Have to use A4 scrap paper. Apply. Okay. So now example number 1. Okay, so example 1. Y x t is equal to 2 sine pi t over pi x. Okay, so we compare this with the general equation y x t a sine omega t minus kx. Okay, so we are then gonna get the omega, which is pi radian per second. Lepas tu the wave number is pi per centimeter, and then k is equal to 2 pi over lambda, which will tells us the lambda punya value, which is equal to 2 centimeter. And then the period of the motion using omega, which is equal to 2 pi over t. So we get the period to be equal to 2 seconds. And then frequency is 1 over the period, which is equal to 0.5 hertz. And then lastly, the wave speed, we can use v equal to f lambda, which gives us 1 times 10 to the power of negative 2 meter per second. Okay, so that is on question A. Now we have to draw the graph of displacement against distance in the range of this. Okay, so let's draw the graph. Okay, we know the amplitude. The amplitude is 1 2 3 1 2 3. Okay, so this is 2 negative 2. This is y, this is x. Y against distance kan. Okay, so the range of x is from 0 until lambda. Lambda is equal to berapa tadi? 2 kan. So this is 1 2 3 4. Sinilah 1 1 2 3 4 5 2. Okay, so they just minta from range 0 until the lambda, which is lambda equal to 2 centimeter tadi. Okay, so this is gonna be in centimeter, and then the y is also gonna be in centimeter lah. Okay, so y, kejap, in the question just now they mentioned okay, y and x in centimeter. Okay, right, so from here we can then substitute x to be equal to, oh bukan, t yang kita substitute. T is equal to 0 seconds. Okay, so t is equal to 0 seconds, which is substitute that into here. X0 equal to a 2 sine pi 0 minus pi x will gives us negative 2 sine pi x. Okay, sorry. So -2 meaning that this graph will start at the negative amplitude, tapi will it start from the origin or not? We're not sure. We can then let x equal to 0. So -2 sine 0 will gives us 0. So yes, it will start from the origin. So our graph will be like this. Kasian juga nih, tidak betul dia punya scale. Try this one. Sorry. Boleh lah tu, begitu. Okay, so our graph is something like this lah. Okay, so they start from the negative amplitude, which is -2 di sini. Okay, so again, if you have no idea how to draw the graph, or whether it starts from the origin or not, just let x is equal to 0 lah. Okay, so that is how you draw the graph for question B. Okay, untuk question C pula. So question C, dia cakap t is equal to at pula. The time taken is half of the period. Okay, so half of the period, we know the period is equal to seconds, then t is gonna be equal to 1 second. Okay, so we gonna substitute t equal to 1 into this equation. So x1 equal to 2 sine pi 1 minus pi x. Okay, so from so from here, this is 2 sine pi minus pi x. Okay, so this is also equal to negative pi x plus pi. So if we use the trigonometry punya rule, which is sine alpha plus minus beta is equal to sine alpha cos beta plus minus cos alpha sine beta, we are gonna get 2 sine pi x. Okay, it is simplified onto jadi yang ini. Okay, so from here we can then draw the graph. This is y, this is in centimeter, x is in centimeter lah. Okay, so the graph is like this. Okay, so if we want to make sure they start from the origin or not, again just substitute x is equal to 0 lah. Okay, so y 2 sine 0, y is equal to 0. So maksudnya at x equal to 0, y is equal to 0, so it starts from the origin, and then we can see that this is a positive amplitude, so the graph will start at the positive axis. Okay, boleh tu macam tu. So this again will only be from the range 1 until 2. Okay, so this is 1, this is 2, this is the amplitude to -2. Okay, so that is the solution for question C. And then question D, we have to sketch displacement against time graph pula at x equal to 0 and half lambda. Okay, so this is y equal to 0, t is equal to 2 sine pi t minus pi which gives us 2 sine pi t. Okay, so again, this is a graph, sine graph starting from the positive amplitude juga. Okay, so y centimeter, this is t in seconds. Okay, don't forget to label every time. So this is gonna be positive amplitude. Again, sine 0 is equal to 0, so it will start from the origin. The graph will start from the origin. Let me just use this one. Okay, so the graph is gonna be something like this. Okay, so dia minta from t until from 0 until 1 oscillation, 1 complete oscillation period kan dia minta. So that is from here until here lah. Okay, so this is mau juga yang besar, baru nampak. Okay, so this is t, this is half t, which is equal to berapa tadi period kita? 2 seconds. So I'm just gonna redo that. This is 2, this is 1 lah. Okay, amplitude, negative amplitude. So amplitude, negative, jangan tulis gitu, lupa pula ada sesuatu value. So this is 2, this is negative 2. Okay, so this one is for the at x is equal to 0. Okay, lepas tu we are gonna do at x is equal to 0.5 lambda. 0.5 lambda? Yeah, 0.5 lambda. So this one I'm gonna do using the second method where you don't have to use trigonometry lah. Okay, so particle is at x is equal to 0.5 lambda. So untuk 0.5 lambda ataupun half lambda, the time taken by the wave to travel this distance is equal to half of the period. Okay, so 0.5 lambda is half lambda, which is this one. Okay, 0.5 lambda. Half of the lambda is just this. So maksudnya the time taken for the wave to travel up until here saja is equal to berapa ni? Half of the period. Okay, so that's why kita boleh let half the period. Okay, so now we can then aduh, kucing saya, sorry ya. So the time taken is actually equal to saya sudah tulis pula, half of the period lah. Okay, so because the wave is propagating to the left, okay, sekarang ni wave propagates to the left. Okay, so if the wave is propagating to the left, we are gonna shift this y-axis here to the left. Sorry. Okay, so sekarang ni kita punya equation is negative kx. Negative kx means the wave is propagating to the right. Okay, so if the wave is propagating to the right, we will shift this axis to the left. Okay, so we try to shift this to the left. Okay, instead of drawing a new one, I'm just gonna add one more here. Okay, copy this. Okay, so sepatutnya ada macam ni lah. Okay, so if we shift this y-axis here to the left, we will then get, now baru saya lukis, we will then get the wave to be, I have to copy this. So we are gonna get the graph to be macam ni lah. Okay, so sebab dia sudah shift to the left. Yang ini dia payah letak sebab dia minta from period from 0 until period sahaja. So from 0 until t saja. So we don't need this one. Okay, so this is y centimeter. This is t in seconds. Okay, so make sure you also label this. Okay, so 2, -2. Okay, boleh. So the rule here is if the wave is to the left, we are gonna shift this y-axis to the right. Tapi kalau the motion is to the right, then we shift the y-axis to the left. Okay, semua ni kita tengok dengan the value of kx, negative ataupun positive. Okay, so negative means wave is to the right, positive means the wave is moving to the left. Okay, alright, I think that's the end of it. Yes, so that is the example for the solution for example number